Good morning students. In today's class we are going to learn about the digital signal processor and its hardware units. So what are the hardware units we are going to implement in the case of digital signal processor? So it has got three different hardware units apart from the normal hardware units such as MAC, which is multiplier and accumulator. So we'll call this multiplier, and the data whatever after multiplication is done, it is saved in the accumulator, hence it is named as MAC, multiplier and accumulator. So here we have got two operands, that is two datas we have taken, which it is of 16 bits. I am going to store it in a 16-bit register named as X register and Y register, and each data it is of 16-bit. So once you perform the multiplication of these two, you will be getting a product which will be more than this 16 bits. That is, the output will be of 32 bits, or sometimes it can be 33 also. So for that I have used a multiplier unit which will multiply, and it will be storing the 32-bit data with the help of an accumulator unit. So this 32-bit data will be stored in the finally in the result register. Suppose if you have a carry, again it will be added in the accumulator part, and this will be converted into, that is scaled down into 32-bit output, and this will be available at the output register, that is named as result register. So this is a special hardware unit which has been used in the digital signal processor in order to perform the multiplication process. And this multiplication is very much important, and this is specially designed hardware unit which is dedicated for doing this multiplication process. So this is what I have told. So it is a special hardware unit which is used for enhancing the speed of the processor. And if whenever you are performing any digital filtering operations, you have to multiply more number of datas, and this specially dedicated MAC will help you in order to perform that multiplication operation. And each operation will name it as a MAC operation. And as I told, it is having 16-bit input data, and the result will be of 32-bit, and we have used the result register in order to store the product. And the second hardware unit, it is the shifter. So this shifter is basically used in order to prevent the overflow. So whenever you do some operations, the result can be more than the assumed data. So we can say that overflow has occurred. So this overflow can be prevented and using the scaling operation. So in order to do the scaling operation, we are making use of this shifters in the digital signal processor. So if I am going to scale up any operation, it shifts the data to the left, whereas scaling down shifts the data to the right, and whereas the scaling up will shift the data to the left side. And also shifting of data to the right, it is equivalent to dividing the data by 2, and then will truncate the fractional part. Whereas shifting of data to the left side, it is equivalent to multiplying the data with 2. So either shifting left or right, we are making use of the shifters. So let us consider an example where you have a 3-bit data as 0, 1, 1. So now I have to shift it towards the right. So if I shift it towards the right, it becomes 0, 0, 1. That is, once you shift to the right, it becomes 0, 1, and the most significant bit, it will be added with 0. So this number, the equivalent number will be 1. So whereas manually if you are going to calculate, you have to take the 3.2, divide with 2, and whatever the result you are getting, in that you have to truncate the fractional part so that you will be getting the result as 1. So it is equivalent to shifting the data towards the right side. And now shift the same data to the left. So what happens? 0, 1, 1. If we shift it to the left, it becomes 1, 1, and the least significant bit, it will be added with 0. So the equivalent number is, just multiply the given number with 2, you will be getting the equivalent number, which is 6, and this 6 seems to be equal to 110. So the digital signal processor, it shifts data by several bits for each data word. So in order to speed up the operation of the digital signal processor, this particular shifter unit, it is used in order to accommodate the scaling operation. So the third hardware unit which is very much important is the address generator unit. So the digital signal processor, it will generate the address for each data to be processed. So for that we have a dedicated hardware unit which is named as circular buffering. So what is circular buffering is, it is illustrated with the help of this particular diagram. So it has got 8 memory spaces where we are going to save the data as x of n minus 1, n minus 2, n minus 3. In a circular manner, we are going to save the data in the circular buffer. So let us illustrate this circular buffering. So in the circular buffering, you can observe always there will be a pointer which will be pointing towards the current data what we are going to feed it. That is, it acts as a first in and first out buffer. So once the next sample, if we are obtaining from the ADC, so the data placed at the location, it will be replaced and it will be pushed out. So now then the location of x of n minus 7 becomes the new location for the current sample, and the original location of x of n becomes the location of the past sample, and this will continue it. And for every new data we are going to input inside the circular buffer, only one allocation is needed, that is only one buffer we needs to update. So this can be better understood if we are going with an example of 2-bit circular buffer. So we have a 2-bit circular buffer here, and for this buffer the data flow, it is in this way, that is we are going to send the data to the circular buffer in the form of A, B, C, D and so on. So initially the buffer will consist of A, B, C and D. So the last data whatever you have input, it will be pointed out by the circular buffer pointer. And when you are going to feed the new data as E, so it will be pushed out, that is the pointer will be pointing to the new data what you have entered. So the equivalent buffer is also given here, it is saved in the first in first out buffer as E, D, C and B. And similarly, if another new data is entered inside the circular buffer as F, so this becomes the current data and the past data will be E. So whereas in the equivalent buffer, it will be saved as F, E, D and C. So this 2-bit circular buffer, whatever I have explained, it is given in the form of points here. So in this way we are going to make use of this circular buffer in order to move the data, and it is the equivalent first in first out buffer, it is also shown in the other side. So in the FAR filtering, the buffer size can reach to several hundreds. For performing this filtering operation, we can make use of this circular buffer, and this circular buffer will significantly increase the processing speed of your digital signal processor. So thanks for watching. Let us continue in the next video. Thank you.